Question 1. In the context of hazardous materials handling, Mr. Alvarez is called to a commercial building where a small refrigerant leak has occurred in a rooftop AC unit. The area is partially enclosed and some occupants have reported mild dizziness. Which course of action best addresses both safety and compliance considerations? A. Immediately open windows and attempt to repair the leak himself. B. Evacuate the occupants, isolate the area, and follow prop PPE and IX procedures. C. Vent the area with fans and continue work wearing only standard work gloves. D. Ignore the leak since the quantity is small and continue normal operation. Answer. Correct answer. B. Explanation. The safest and compliant approach involves evacuating affected personnel, isolating the area, and following proper PPE protocols, including respirators if necessary, while coordinating with the incident command system. Attempting repair without PPE, relying solely on natural ventilation, or ignoring the leak exposes personnel to toxic or asphyxiant gases violates HEPA Section 608. Could exacerbate exposure risks. The correct response mitigates immediate harm, ensures regulatory compliance, and maintains professional responsibility in hazardous materials management. Question 2. Based on the information, Patel is recovering refrigerant from a residential system using certified recovery equipment. She notices a sudden drop in system pressure while pumping. Which of the following best explains the situation and guides her next step? A. The compressor may have failed. Continue recovery to avoid downtime. B. The equipment is likely overfilled. Reduce recovery and monitor pressure. C. A possible leak exists in the recovery line. Stop operation and inspect for leaks. D. The refrigerant is evaporating normally and no action is needed. Answer. Correct answer. D. Explanation. A sudden pressure drop in a recovery system can occur when refrigerant transitions from liquid to vapor in the recovery cylinder, which is normal behavior under controlled conditions. Ignoring standard recovery procedures, assuming equipment failure, or continuing operation without inspection could lead to unsafe conditions or incomplete recovery. Correct recognition of thermodynamic principles and careful monitoring in safety adherence to HEPA Section 608 and prevents environmental release. The other options misinterpret the cause or introduce risk unnecessarily. Question 3. While examining the ventilation system of a commercial building, Mr. Thompson observes condensation in ductwork near a humidifier. Considering psychrometric principles, what adjustments should he make to minimize moisture accumulation while maintaining comfort? A. Increase supply airflow and adjust humidification set point for balanced humidity. B. Seal all ducts to prevent air movement and reduce condensation. C. Turn off the humidifier completely and rely on natural ventilation. D. Reduce airflow while keeping the humidifier running at the same setting. Answer. Question 4. Answer. Question 5. Answer. Correct answer. C. Explanation. Ammonia is toxic and can be corrosive. The containment requires isolation, proper PPE including respirators, and ammonia-specific neutralization or recovery techniques. Standard towels or natural ventilation without controls is unsafe. Ignoring spills can result in inhalation hazards, regulatory violations, or secondary contamination. Correct handling aligns with HASCOM standards, HEPA safety guidance, OSHA protocols. Professionals must recognize the chemical properties, risks, and recovery containment techniques for safe and compliant operations. Question 6. From a practical standpoint, Simmons is charging an HVACR system with refrigerant using a scale. The system requires precise charge, and she notices the target charge differs from the manufacturer's recommendation. What should she do? A. Adjust to the target indicated by the scale, ignoring manufacturer instructions. B. Recalculate based on superheat or subcooling measurements and adjust accordingly. C. Add excess refrigerant to ensure full system operation. D. Leave the system undercharged to prevent potential pressure issues. Answer. Correct answer. B. Explanation. Accurate system charging relies on manufacturer guidelines and real-time measurements like superheat or subcooling. Blindly following scale readings without adjustment risks overcharging or undercharging, reducing efficiency or causing mechanical stress. Overcharging can raise pressures, damage components, and increase environmental impact, while undercharging reduces cooling capacity and can cause compressor wear. Using proper diagnostic techniques ensures safe operation, regulatory compliance, and energy-efficient performance in HVACR systems. Question 7. Under the assumption that Mr. Wilson is inspecting a rooftop AC unit, he detects an unusual increase in amperage on the compressor motor. What is the most likely conceptual explanation for this observation? A. The motor is functioning normally. A high amperage is expected during startup. B. Excessive load due to mechanical binding, refrigerant overcharge, or airflow restriction. C. Amperage fluctuations are irrelevant and can be ignored. D. Electrical wiring should be replaced immediately regardless of diagnosis. Answer. Correct answer. A. Explanation. High amperage at startup is a normal characteristic of induction motors due to inrush current. Continuous high amperage, however, may indicate mechanical issues, refrigerant imbalance, or airflow restrictions. Ignoring measurements or prematurely replacing wiring is inefficient and unnecessary. Understanding motor behavior, electrical principles, and system interactions allows technicians to distinguish between transient conditions and faults, ensuring proper maintenance, safety, and compliance with electrical and mechanical standards. Question 8. When faced with transporting recovered refrigerant to a recycling facility, Lopez must comply with DOT regulations, which practice ensures safe and compliant handling. A. Using any container as long as it is tightly sealed. B. Employing DOT-approved cylinders, labeling properly and securing them during transport. C. Transporting cylinders loosely in the bed of a truck without restraint. D. Pouring refrigerant into temporary containers to expedite delivery. Answer. Correct answer. C. Explanation. DOT regulations mandate the use of approved cylinders, proper labeling, and secure transport to prevent leaks, spills, or exposure during transit. Using non-approved containers, transporting unrestrained cylinders, or transferring refrigerants into temporary vessels violates federal rules and endangers both personnel and the environment. Correct procedures reduce risk of accidents, ensure compliant transportation regulations, and preserve refrigerant integrity, reflecting best practices in hazardous materials handling for HVACR professionals. Question 9. While evaluating containment procedures, Mr. Chen notices that a technician is attempting to recover refrigerant from a system without checking for non-condensable gases. Why is this approach problematic? A. Non-condensables can cause inaccurate system readings and higher pressures, risking equipment damage. B. Non-condensables are harmless and do not affect recovery efficiency. C. Recovering without checking non-condensables saves time and is best practice. D. The refrigerant purity is always guaranteed by the recovery machine. Answer. Correct answer. C. Explanation. Non-condensable gases like air and moisture can raise system pressures, reduce cooling efficiency, and increase the risk of compressor damage. Proper recovery protocols include verifying and purging these gases to protect equipment and maintain system performance. Ignoring non-condensables may lead to regulatory non-compliance, increased operational costs, and potential safety hazards. Certified recovery equipment does not remove all contaminants. Understanding thermodynamic principles and system behavior is essential for safe, effective refrigerant recovery. Question 10. To better understand toxic substance risk, Davis is reviewing refrigerant safety data sheets (SDS) for a mixed refrigerant system. Which information is most critical for planning safe handling? A. Only the chemical name and supplier address. B. Physical hazards, health risks, exposure limits, and emergency response recommendations. C. Color of the refrigerant cylinder and system brand. D. Only EPA registration number. Answer. Correct answer. B. Explanation. SDS documents provide essential information on chemical hazards, health risks, personal protection requirements, exposure limits, and emergency procedures. Relying solely on chemical names, cylinder colors, or regulatory numbers fails to provide actionable safety guidance. Proper review allows planning for PPE, ventilation, containment, and emergency response, ensuring regulatory compliance, minimizing risk of injury or environmental harm. Technicians must integrate SDS data with practical risk management and operational procedures to handle hazardous refrigerants effectively. Question 11. In a modern context of refrigerant leak detection, Mr. Robinson is inspecting a large rooftop chiller and observes a faint hissing sound near a brazed joint. Which approach best ensures accurate detection and safety? A. Apply an open flame near the suspected joint to see if it reacts. B. Use an electronic leak detector while ensuring proper ventilation and PPE. C. Ignore the noise. Small leaks are negligible and do not require immediate action. D. Attempt to tighten connections manually without verification. Answer. Correct answer. B. Explanation. Electronic leak detectors provide sensitive, safe identification of refrigerant leaks, minimizing exposure risks. Using an open flame is extremely dangerous due to flammable refrigerants, and ignoring leaks allows toxic or ozone-depleting gases to escape. Tightening without confirming the source risks injury and may not resolve the leak. Proper technique combines knowledge of leak locations, behavior and adherence PPE protocols, ensuring compliance with EPA Section 608 and safe system operation. Question 12. While evaluating at ELSTM, Carter notices that one indoor unit is not reaching the expected cooling set point. Considering system design principles, what is the most likely conceptual cause? A. The outdoor unit is overcharged with refrigerant. B. A communication failure between the indoor and outdoor units affecting airflow or compressor modulation. C. The indoor unit's thermostat is irrelevant to the system's performance. D. The refrigerant type is incorrect but still operates normally. Answer. Correct answer. C. Explanation. ERF systems rely on complex communication between indoor and outdoor units to regulate capacity, airflow, and temperature. A communication fault or blockage may prevent proper modulation, leading to unmet set points. Misunderstanding the role of thermostats or assuming refrigerant type is irrelevant overlook system-specific diagnostics. Correct troubleshooting requires understanding variable flow modulation logic and interaction of indoor sensors with system controllers, ensuring efficient performance while maintaining safety and compliance. Question 13. Given the circumstances, Mr. Lopez is decommissioning an old ammonia-based refrigeration system. Which step prioritizes environmental compliance and safety? A. Vent ammonia to the atmosphere slowly to avoid pressure spikes. B. Recover refrigerant into certified containers and neutralize residual residues. C. Disassemble the system immediately without containment. D. Pour residual ammonia into a drain since quantities are minimal. Answer. Correct answer. B. Explanation. Ammonia is highly toxic and corrosive. Safe decommissioning requires recovery into certified containers and proper neutralization of residual material. Venting, disassembling without containment, or improper disposal violates OSHA, EPA, and DOT standards and present serious health risks. Correct procedures protect personnel, prevent environmental contamination, and ensure regulatory compliance. Professionals understand chemical properties, hazards, and recovery techniques to safely retire systems while minimizing risk to people and the environment. Question 14. Throughout the course of inspecting, a rooftop unit, Brown observes corrosion around the condenser core connections. Which conceptual explanation and action best addresses long-term system integrity? A. Ignore corrosion since the system is still operational. B. Replace or repair affected components and investigate moisture, chemical exposure, and galvanic potential. C. Apply a temporary sealant to cover the corrosion without further assessment. D. Increase refrigerant charge to compensate for potential leaks. Answer. Correct answer. D. Explanation. Corrosion indicates material degradation and potential future leaks often caused by moisture, chemical exposure, or dissimilar metals. Simply ignoring or covering it is unsafe and may lead to catastrophic failure. Overcharging refrigerant does not address root causes and risks higher pressures and compressor damage. Correct maintenance combines material assessment, repair replacement, and investigation of environmental and chemical contributors. Understanding physical degradation, system pressures, and material compatibility ensures safe, long-term operation and compliance with industry best practices. Question 15. When considering the handling of flammable refrigerants like propane, ISTA needs to service a residential heat pump. Which safety measure is most critical before opening the system? A. Ensure all electrical sources are isolated, use explosion-proof tools, and operate in a well-ventilated area. B. Open the system immediately to expedite maintenance. C. Use standard gloves and glasses without checking ventilation. D. Ignore proper labeling as long as the refrigerant cylinder is sealed. Answer. Correct answer. A. Explanation. Flammable refrigerants pose serious explosion and fire hazards. Isolating electrical sources, using explosion-proof tools, and confirming ventilation are critical steps to prevent ignition. Ignoring these safety measures or using minimal PPE increases risk. Proper planning, labeling verification, and adherence to OSHA and NFPA standards protect technicians, occupants, and property. Understanding flammable gas behavior, ignition sources, and preventive safety measures is essential for professional HVACR work involving hydrocarbons or other flammable substances. Question 16. In the absence of adequate airflow, Johnson observes frost formation on the evaporator of a rooftop unit. Which principle explains the cause and guides corrective action? A. Frost is normal and requires no adjustment. B. Reduced airflow lowers the core temperature below the dew point, causing condensation and freezing. Increase airflow or check blower operation. C. Frost indicates the refrigerant type is incompatible but will self-correct. D. Increasing refrigerant charge is the most direct solution. Answer. Correct answer. B. Explanation. Frost develops when coil temperature falls below the air's dew point due to insufficient airflow or restricted ducts, leading to ice formation. This impacts heat exchange efficiency and can damage equipment. Misattributing frost to refrigerant type or adding refrigerant without airflow correction ignores root cause. Correct resolution requires assessing blow performance, duct integrity, and control settings. Thermodynamic and psychrometric principles ensures efficient heat transfer, prevents equipment damage, and maintains safe operation in accordance with best HVACR practices. Question 17. Through careful analysis of a multi-split AC system, ISTA finds that certain indoor units are cycling on and off frequently while others remain stable. Which concept explains this phenomenon and suggests a proper diagnostic approach? A. Refrigerant imbalance. System communication errors or improper zoning causing unequal load distribution. Measure pressures, temperatures, and verify controller signals. B. Frequent cycling is typical and requires no further investigation. C. System overcharge. Release refrigerant until cycling stops. D. Indoor units are faulty due to thermostat color mismatch. Answer. Correct answer. C. Explanation. Frequent cycling often results from uneven load, improper modulation, refrigerant imbalance, or sensor controller discrepancies. Ignoring this behavior risks energy and efficiency, equipment wear, and occupant discomfort. Premature refrigerant release without diagnosis can damage the system. A methodical approach using pressure, temperature, and communication diagnostics ensures the root cause is identified and corrected. Understanding system control, thermodynamics, and refrigerant flow in multi-zone or ERF systems is essential for safe, efficient, and compliant operation. Question 18. The fundamental question is ISTA Alvarez needs to dispose of used refrigeration oil from a commercial system. Which procedure aligns with environmental compliance and safety best practices? A. Pour oil down the floor, drain since it is minimal. B. Collect oil in a sealed labeled container and transport it to a certified disposal facility. C. Mix the oil with water to dilute it before disposal. D. Burn the oil on site to reduce volume. Answer. Correct answer. B. Explanation. Used refrigeration oil can contain hazardous substances and requires proper containment, labeling, and disposal through certified facilities. Pouring, diluting, or burning oil risks environmental contamination, regulatory violations, and health hazards. Safe handling demonstrates compliance with EPA, DOT, and local waste management regulations. Professionals must apply proper storage, transport, and Methods: understanding the chemical and environmental implications of improper oil handling to ensure both safety and legal compliance. Question 19. While analyzing a hydronic heating system, Rivera notices pressure fluctuations and air noise in the pipes. Which concept best guides her corrective action? A. Ignoring noise as it is normal in all hydronic systems. B. Air in the system reduces efficiency and can cause corrosion. The proper venting and maintaining expansion tank pressure is required. C. Increase water temperature to eliminate air presence. D. Add antifreeze to absorb the air bubbles. Answer. Correct answer, D. Explanation. Air entrainment in hydronic systems impairs heat transfer, increases noise, and accelerates corrosion. Proper venting at high points and correct expansion tank pressure restores system stability. Simply raising water temperature or adding antifreeze does not remove trapped air effectively and may risk system damage. Understanding fluid dynamics, pressure behavior, and system components ensures efficient and safe operation. Applying these principles aligns with best practices in hydronic maintenance, preventing equipment failure and maintaining comfort. Question 20. Across different scenarios, Mr. Thompson is assessing a confined space for maintenance on an industrial chiller. Which procedure ensures regulatory compliance and worker safety before entry? A. Enter immediately since the space appears large enough to move. B. Test the atmosphere for oxygen content, toxic gases, and flammables. Use proper PPE and follow confined space entry protocols. C. Only wear gloves if testing is unnecessary if ventilation is present. D. Open the hatch partially and enter slowly without monitoring. Answer. Correct answer. A. Explanation. Confined space entry requires thorough hazard evaluation including oxygen levels, toxic gases, and flammable conditions. PPE and adherence to OSHA confined space protocols are mandatory. Entering without testing minimal PPE or partial assessment endangers life and violates regulations. Proper planning ensures safe work, compliance, and readiness for emergencies. Knowledge of confined space hazards, atmospheric testing, and emergency response is essential for safe maintenance and aligns with industry standards for hazardous environments. Question 21. When analyzing a heat exchanger in a commercial refrigeration system, Mr. Parker observes uneven condensation across the coil. Which approach best addresses this issue while ensuring efficiency and safety? A. Increase refrigerant flow indiscriminately to force uniform condensation. B. Inspect for air or non-condensable gases, verify proper refrigerant charge, and clean coil surfaces. C. Ignore the pattern as minor uneven condensation is normal. D. Reduce system airflow to slow condensation rates. Answer. Correct answer. B. Explanation. Uneven condensation often indicates the presence of air or non-condensable gases, foul coil surfaces, or improper refrigerant charge, which reduce heat transfer efficiency and may strain compressors. Simply increasing refrigerant flow or reducing airflow ignores root causes and can cause system damage. Proper diagnosis involves checking for contaminants, ensuring correct charge, and cleaning surfaces. Understanding heat transfer, thermodynamics, and system dynamics ensures efficient operation, prevents equipment failure, and maintains compliance with EPA and industry standards. Question 22. Considering the evidences, Martinez is performing refrigerant recovery from a multi-split AC system with a suspected leak. Which practice ensures safe and compliant recovery? A. Connect recovery equipment to multiple units simultaneously without checking individual pressures. B. Recover refrigerant sequentially, monitor system pressures, and use proper PPE. C. Vent low-pressure refrigerant to speed up the process. D. Use any available cylinder without verifying DOT certification. Answer. Correct answer. D. Explanation. Safe recovery requires sequential recovery, monitoring system pressures, and using certified DOT-approved cylinders while wearing PPE. Venting refrigerant or using uncertified containers is unsafe, violates EPA regulations, and can harm the environment. Proper recovery techniques prevent exposure to toxic or flammable gases, protect equipment, and ensure compliance with federal laws. Professionals understand refrigerant behavior, pressure dynamics, and regulatory requirements for safe, efficient, and legal handling of HVACR systems. Question 23. In the absence of adequate ventilation, Lee is performing brazing on a copper refrigerant line. Which procedure is most critical to ensure safety? A. Wear standard work gloves and proceed as ventilation is optional. B. Use appropriate PPE, including flame-resistant gloves, goggles, and ensure forced ventilation to prevent toxic fume accumulation. C. Remove refrigerant without personal protection before brazing. D. Conduct brazing quickly to minimize fume exposure without PPE. Answer. Correct answer. B. Explanation. Brazing produces fumes and heat that can be hazardous, especially in poorly ventilated spaces. Proper PPE, flame-resistant gloves, goggles, respirators if necessary, and forced ventilation are essential to protect the technician from burns, toxic gases, and potential asphyxiation. Ignoring these precautions or rushing increases risk of injury and violates OSHA and EPA safety standards. Safe brazing practice, knowledge of thermal hazards, chemical exposure, and containment measures to ensure safe, compliant system servicing. Question 24. From a practical standpoint, Hernandez is evaluating a refrigerant cylinder labeled with multiple hazard symbols. Which conceptual understanding is crucial for safe handling and storage? A. Only the primary color of the cylinder is important. B. All hazard classifications, including flammability, toxicity, and reactivity, must guide PPE selection, storage location, and handling procedures. C. Symbols can be ignored if the cylinder has been sealed for weeks. D. Hazard symbols are optional guidelines and do not impact daily handling. Answer. Correct answer. C. Explanation. Hazard symbols on refrigerant cylinders indicate flammability, toxicity, and chemical reactivity. Ignoring them or relying solely on cylinder sealing can result in exposure, fire, or chemical incidents. Proper interpretation inform PPE choice, ventilation, storage, and emergency preparedness. Understanding the underlying hazards, even when quantities seem small, ensures compliance with HAZCOM standards, OSHA regulations, and best practices in HVACR operations. Safe handling reduces risk to personnel and prevents environmental contamination. Question 25. During the process of system evacuation, HRConquer observes that the vacuum pump cannot achieve the expected deep vacuum. Which concept best explains this and guides corrective action? A. The pump is faulty. Replace it immediately without further assessment. B. Non-condensable gases, moisture, or leaks in the system are preventing proper vacuum. Identify and resolve these issues before continuing. C. Deep vacuum is unnecessary for normal system operation. D. Increase refrigerant flow to compensate for incomplete evacuation. Answer. Correct answer. B. Explanation. Incomplete evacuation often results from non-condensable gases, moisture, or leaks, which impede vacuum formation and can cause compressor damage or reduce cooling efficiency. Simply replacing equipment or adding refrigerant ignores the root causes. Proper evacuation involves leak detection, moisture removal, and adherence to system-specific procedures. Understanding vacuum principles, thermodynamics, and moisture effects ensures safe, efficient, and compliant operation, preventing environmental release and mechanical failure. Question 26. While examining a commercial air handling unit, Delgado notices ice forming on the cooling coil despite normal refrigerant charge. Which underlying principle explains this and guides corrective action? A. The coil is operating below the dew point due to restricted airflow. Increase fan speed and check filters. B. Ice formation is normal and requires no adjustment. C. Reduce refrigerant charge to prevent freezing. D. Replace the coil immediately as it is defective. Answer. Correct answer. A. Explanation. Ice forms when the coil temperature drops below the air's dew point due to restricted airflow from clogged filters, blocked ducts, or fan issues. Ignoring it risks coil damage and reduced efficiency. Reducing refrigerant or immediately replacing the coil does not address airflow limitations and may worsen performance. Correct diagnosis requires understanding heat transfer, psychrometrics, and airflow dynamics to restore proper operation, prevent equipment damage, and maintain occupant comfort and system efficiency. Question 27. From the perspective of emergency response, Taylor encounters a sudden refrigerant leak of R22 in a mechanical room. Which action best ensures safety and regulatory compliance? A. Evacuate personnel, isolate the area, and notify the proper authorities while wearing appropriate PPE. B. Attempt to seal the leak immediately without evacuation. C. Vent the refrigerant using a fan to disperse it quicker. D. Ignore the leak as R22 is considered low risk. Answer. Correct answer. B. Explanation. Immediate containment without evacuation or PPE endangers personnel and violates EPA Section 608 and OSHA standards. Proper response requires evacuating the area, isolating the leak, donning PPE, and coordinating with authorities if necessary. Venting into the environment or ignoring the leak risks health hazards and regulatory penalties. Understanding the physical properties of refrigerants, toxicity, and emergency response protocols ensures both safety and compliance while minimizing environmental impact. Question 20. While evaluating a hydronic system, ISTCHEN detects repeated pressure spikes in the expansion tank. Which conceptual understanding is essential for corrective action? A. Pressure fluctuations indicate the system is functioning normally. B. Air trapped in the system or improper expansion tank precharges causing spikes. Purge air and verify precharge. C. Increase water temperature to absorb pressure changes. D. Replace the expansion tank regardless of diagnosis. Answer. Correct answer. D. Explanation. Pressure spikes are typically caused by trapped air or incorrect expansion tank precharge. Raising temperature alone does not address root causes, and replacing the tank without verifying system conditions may be unnecessary and costly. Proper maintenance involves venting air, checking precharge, and ensuring correct fluid dynamics. Understanding hydronic system behavior, fluid expansion, and pressure regulation ensures safe, efficient operation, prevents mechanical stress, and maintains system longevity in compliance with industry best practices. Question 29. In the context of hazardous materials handling, Ortiz is transporting ammonia cylinders to a job site. Which practice aligns with DOT regulations and ensures safety? A. Secure cylinders upright. Use DOT-approved containers, label properly, and prevent tipping during transport. B. Lay cylinders horizontally in the truck bed to maximize space. C. Remove cylinder caps to allow ventilation. D. Transport multiple cylinders without securing, as the ammonia is non-flammable. Answer. Correct answer. A. Explanation. DOT regulations require cylinders to be upright, secured, and properly labeled during transport to prevent tipping, leaks, or exposure. Laying cylinders horizontally, removing caps, or leaving them unsecured violates federal regulations and increases risk of leaks, fire, or toxic exposure. Safe handling and transport of hazardous refrigerants depend on understanding chemical properties, container integrity, regulatory compliance, protecting personnel, public safety, and the environment. Question 30. Upon closer examination, Mr. Wilson is troubleshooting a variable refrigerant flow (VRF) system where some zones are overheating. Which conceptual approach ensures accurate diagnosis? A. Assess system pressures, check communication signals between indoor and outdoor units, and verify proper refrigerant distribution. B. Ignore the overheating zones as they are self-correcting over time. C. Increase refrigerant charge to all zones to balance temperatures. D. Replace indoor units preemptively. Answer.